In this example, we will use this image to help solve sine of theta equals 1/3 for all angle measures theta. This example will also demonstrate how we can come up with the full infinite solution set when using an inverse trigonometric function, in this case arcsine, to find all angle measures of theta. Let's start with the beginning. If I have just sine of theta equals 1/3. If my goal is to get theta by itself, what I'm going to do is apply the inverse sine function, or arcsine, to both sides of this equation. For example, I will have here arcsine of sine of theta is equal to arcsine of 1/3. What that will allow me to do, similar to when taking a root of two sides where you have an exponent, it will allow me to cancel out the function of sine in order to have simply theta is equal to arcsine of 1/3. However, this is only going to give me one solution, which the first picture above is demonstrating. Arcsine of 1/3 is only going to give me one single angle measure, and it will give me an angle measure in quadrant 1. I know this because of how arcsine works. Arcsine has to be an angle measure between negative pi halves as well as pi halves. Because the ratio I'm working with is a positive 1/3, it will give me an angle measure specifically between 0 and pi halves, or in quadrant 1. That will be the first angle measure it provides. However, that's not the full solution, because sine of theta equals 1/3 is not asking the same question as arcsine of 1/3. Arcsine of 1/3 itself only has one answer. However, sine of theta equals 1/3 should have many answers. There are many angle measures where sine should equal 1/3, just like there are many angle measures where sine equals 1/2. Not just at pi over 6, but at any coterminal angle measure for that. Meaning, arcsine of 1/3 is not just the full picture, but we should be able to also add another 2 pi, another 4 pi, another 6 pi, or subtract some amount of 2 pi in order to get other coterminal solutions. So, arcsine of 1/3 is part of the solution, but if we consider any coterminal angle measure, so adding 2 pi k where k is an integer, then that will get us closer to the solution. I say closer because that's still not the final answer. Look at our original question. Sine of 1/3, or sine of theta is equal to 1/3. Well, that shouldn't only happen in quadrant 1, because sine equals positive ratios also in quadrant 2, as demonstrated with the second picture we have here. We should have another angle measure in quadrant 2 that has the same reference angle, or is the same distance from the x-axis. Well, if we want to find what this angle measure is, which has the same reference angle as the one we had in quadrant 1, well then all we really need to do is find what happens when we go all the way to the negative x-axis, which is pi, and then we go back that amount that we determined from quadrant 1. Meaning we should also have another solution set that is pi minus that angle measure from quadrant 1, arcsine of 1/3, and just like the previous solution sets, we should also consider any coterminal angle measure where k is an integer. These two sets that we have here, arcsine of 1/3 plus 2 pi k, as well as pi minus arcsine of 1/3 plus 2 pi k, These two solution sets together comprise all angle measures, where sine of theta is equal to 1/3.